Hello, everybody. Welcome to week 4, or perhaps week 5 if you consider the break of Geometry A here. Hope everybody's doing well, had a good holiday. We are now 1 week back, second week back, right? Beginning. And hope everybody's getting into the swing of completing our lessons. And so just to keep in mind, last day will be Friday, March 1st. So we still have several weeks to go. If you do need extra help, you have my link there to schedule time with me. Not too many people do that because you can also just message me or text me, and I do respond almost immediately. So today, our learning intentions and success criteria is I am learning to complete a proof table, and the success criteria really will be that you've copied the proof table that I will show you. That does not seem like a high bar, but you need to be relaxed to know and see that you can do this. So, so there's just a reminder of when, oh, that's not correct. We're here Mondays and Fridays. Next session will be at 3 o'clock on Friday. So all of this, skip through a lot of this. We do have math tutors available. So you can go to the class syllabus and select a time that is convenient for you. And this is just a word about reminder to use the grading rubrics in discussions and the blue text that I add to the prompt and to the instruction pages for discussions and projects. Most of my help is honestly just referring you back to that help that I've already given you, but I'm always here to answer any questions. So that's up soon. And this is again, just a review here, maybe take a screenshot, different ways you can reach me. And then again, just when we meet Mondays at 11, Fridays at 3. So that's getting this kind of out of the way, and let us get into our actual learning intentions and that success criteria. So I'm going to show you checkpoint 10. We are going to go right to that. Go back. Sorry for this delay. Sorry. So this is lesson 10, and it's the checkpoint, and this is actually question 4 from the course. So I'm going to walk through how I think about this. And the word I is important because there are many ways to write a proof table for information that you are given and what you're looking to prove. So you do need to know the way the person who wrote the proof table, what, what they were thinking, what their approach was, what they were looking at when they wrote it, what they were thinking about, because there's many ways to do it. And that's why I want you to copy this, and the learning intention is basically to get a feel for these proof tables, to know what to look for, what you're looking at, what to see, and to the success criteria is just to copy this, right? I'm all about copying. That's how we learn. So I'll first go through the parts. You know, what at a high level, what are we looking at here? What are the parts? So at the top, we have this given information. There's 3 lines. Sometimes there's only one. 3 is really the most you'll ever see if that information that you are given. You need these truth statements about um, the situation. The next after the given is what you are proving, the statement. Here it is triangle ABC is congruent to triangle ADE. How to see this is very, very important. It looks like it's just alphabet letters that are put down, but there's more here. What I want you to see here is, well, first we are talking about 2 triangles, right? We can see those. So that's what the triangle represents. A, B, C, 1, 2, 3. Those positions are meaningful. 1, 2, and 3, right? These are the vertices are the corners. So A is the common one right there to both triangles, right? B and C. So we're reading this triangle. This is very important. A, B, and C. Okay, this left to right. So now when this is like an English sentence, but it's math symbols, left to right, A, B, C. The next one, A, D, E. A, D, E. What else do we, another thing you see here is we go from A to B. A to B has the 2 tick marks. Look over here, A to D, 2 tick marks. So these 2 are the corresponding segments. You can put segments mark over it. What about BC? We go here from B to C. There's no tick mark there. What about over here, D to E? D to E, there's no tick mark over there. Well, those are the corresponding sides, right? Remember, when you learn about finding the area of a triangle, we would call those the bases, right? Perhaps, you know, but anyhow, the point is that those are corresponding, okay? Even though they don't have a tick mark, corresponding means that in our proof being that we want to show these triangles are the same size and shape, those are the pair. Those are the pair that we're going to compare. So that's just very important in how we read this geometry, how the symbols, the letters correspond to the picture. So I'm going to clean up this now. I hope that that was just maybe kind of, shows you a little bit of obviousness, not when you first look at it, but when I mention it to you and I point that out to you. Because you'll see that you can even prove things just by looking at the way those 3 letters are written. It tells you a lot. We'll get into more of that here. I'll clean this up. I showed you how to read, move from the name of a triangle to the triangle itself, the image. Clean this up also. Hopefully you're taking notes, right? Maybe you want to come back and watch this later. Eraser's being very fussy. Okay, so now it's all clean again. So that's the given, the proof part, the image part. Now let's go down to the actual table. And the instructions are to match each statement in the proof to the correct reason. Well, we can add some labeling here that they have not given us. But we want to make this more user-friendly. So these are statements on the left side. Every proof table in any textbook you see has the statements on the left and the reasons for them being true on right. The reasons that they are true are here in this column. And so throughout the course, we are going to be completing the reasons, giving the reasons for these statements to be true. So I'm just going to put out the question here to those here in the live session, to Brent, Herkiba, and Taryn. Do you have any questions so far? Any comments? Did you learn anything there? Was anything new? Was it review? And where are you at briefly? Say I didn't. You're good. Thank you, Taryn. It's helpful if if you're seeing new information, you can just put this as new, just kind of echo, let me know what's going on. Thank you, Taryn, Herkiba, and Brent. Hopefully you're doing okay also. Seeing how to read this should give you a little comfort factor, a little bit of typing. So so when you read this, you're not just looking at this, but you are putting words to the symbols. So let's start with the first line. There's 1, 2, 3, 4. They're numbered. It's very common in proof tables because there's a logical order to these statements. Sometimes the reason for one to be true is because of the line or other lines that came before it, further up the table. So let's read the first statement, line 1. And you don't want to just look, but you want to read it with words. Segment AC is congruent to, means it's just as long as, equal length, as segment AE. So, but you want to see it, right? AC. So it's telling us that AC here is congruent to AE, right? That's what this is telling us. AB is congruent to AD. It's telling us that. Right? This is the how-to, reading a proof table. Then the third part is angle CAB. CAB, that's the top, right? Well, the top one on the top right is a rotation of EAD. Excuse me. So the meaning for that, of the lower one, the meaning for that is we saw in the discussion earlier, lesson 8 discussion, that when we move or rotate figures, they are still congruent, right? That was the big lesson. That was the big part of lesson 8. But we did talk there, we learned about rotation rules. Translation is sliding, rotation is turning. So that, so that we can accept that. And if you always want to look at this first statement, try to find it up here. It's exactly the same thing. Exactly the same. So this is given. And almost always the first statement, line 1 in a proof table, will be given. Not always, but usually. So we're done with that. We're going to see what's the next thing. So from here on, it's going to be logic. It's going to be deduction. Line 2. I'll change the color here for line 2. Line 2, the measure, remember, read the words, not the letters. Measure of angle CAB, that's this angle, CAB. And you can use some color. If you have colored pens, it helps. CAB is the rotate. Oh, sorry, I marked the wrong area. We're done with that. Here, the measure of CAB is equal to the measure of angle EAD. Those are equal. The reason for that is that here's the way that I remember this. Think of, we can add some imaginary context. These are scissors. And this angle and this angle and this angle and this angle, you do a little imagination. As you open and close the scissors, the opposite angles are always equal. The measure of the opposite angles are always equal. And the reason that we name that idea, I call it a scissor idea, but they don't like that. They get all fancy. And it's called their vertical angles. Vertical angles. This is very common in lots of proof tables you'll see. See this a lot of times going forward, vertical angles. There's a reason they're not called horizontal angles, and I don't even know that. I don't know. I can say you have to stick with one. That's the name they chose. There's a fancy reason. But just know that it's vertical angles. Line 3. Any questions on that? Every time you see that now in an image, even if they don't give it to you, you'll know because of this that it's an example of vertical angles. Line 3, change my color again. Line 3, angle CAB is congruent to CAB. So it's the same, right? This was the measure of, and this is the angle itself. The angle itself, they are congruent. Now there can be different reasons for this, and that's why I'm having you copy this. So it could be, now we do have multiple choice, so you're going to choose the right answer that they expect there. But it could be because vertical angles are always congruent. And this is the word, this is the congruent. This means congruent. So one thing could be that you might find in multiple choices definition of congruent angles. Sorry, vertical angles is that the angles are themselves congruent. I'm going to ask you your patience again. Hold on 1 second. So happened I was thinking like the person who wrote the question. So this is definition of congruent angles. It's the definition of congruent angles. I'm just going to write this congruent. Well, I'll write in the word congruent, and then I'm going to draw the picture of angles. congruent angles, apostrophe S. This is the vertical angles are congruent. Okay, remember the success criteria for you is that you are writing this out. So we went from the measure of the angle because we saw their vertical, right? This is me, this is you, and we are looking at that. I didn't need to erase that, cross it out. So we are literally looking at this image and we are adding that depth of meaning that, hey, scissors, those are the same. Those are called vertical angles here in red. We know that they are congruent when we open and close the scissors. So we are naming them and knowing the definition because of, right, we're adding that meaning, the layers of meaning for the definition of congruent angles. So we see the congruent here, and we see the congruent there in the choice, right? Any comments or questions here? See some typing, but I don't see anything being posted. Don't be concerned about what you type in the chat. Any ideas that you see are good. We'll move ahead. We're 22 minutes into this one image, right? Plus a little bit of a preview. Line 4, we read this. Triangle ABC is congruent to triangle ADE. I'm going to change my color again. This, right, is what we're proving. And it is going to be, not always, but almost always the last statement in the proof. Okay, almost always the last statement in the proof. They will always give you the statements. We are filling in the reasons on the right. Well, now this also really, really, really important here, okay? So I'm going to pause the recording really quickly. So again, this is extremely important, this last part. I'm going to clear my markings here. So I'm going to add another layer of how to see. What are we looking at? What is in front of us? I don't know how much I need to erase. It's stubborn. Okay, I'm just going to leave the last dot there. It doesn't matter. So let's now learn how to read line 4. Triangle ABC is congruent to triangle ADE. So here's what we have. We have a side 1, side 1 of this triangle, okay, because it's the double. Doesn't matter if you begin with the single or the double. But here they have AB and AD. And then they have BC. Let's see here. We have this. So we have angle. Angle 1 in this triangle. The 1 represents the first triangle. This is angle 2, right, because of vertical angles. Now we have side 2, and this is side 2, right, the single tick marks. So what you see here is, as you read this in order, right? We're going to read it this way, or you can go counterclockwise. It doesn't matter, right? Go this way or this way. And what you see is this: side, angle, side. These are congruent. They are all the same length or angle measure, same size, same width of the angle. So this is the side angle side congruence postulate. Now I'm going to just highlight some really fine points for you so you are not confused, okay? Early in the course, I told you that if you have any conditions in any kind of a statement anywhere, if you see the word if, it's a theorem, otherwise it's a postulate. So I don't want you to get hung up on that. So this really, you can really ignore. I mean, it is a choice, but don't get hung up on all of this, on those words. This is what is important. The side angle side, side angle side. As I show you more proofs as we go through the course, you'll see how just looking at this, right, you would know that we're going to end up with side angle side, even if you didn't have the multiple, the choices to choose from. Side angle side, and then you have the congruence and postulate. But don't let these big words scare you, because you can just use your eyes and know what to do, by looking side angle side before you even get through all the proof tape, all of the proof. That does come with, of course, with experience, to be able to see things that they want you to see. Well, that's really what I have for you. We're 28 minutes into the recording, so I've kept this just about 30 minutes. I hope this was helpful. I do recommend that you watch this again, even if you speed watch it, anything you see you want to stop at. There will be several proofs in the course, but I'll help you through any of them. So just again, do it from those here, for those here in the session. Any questions or comments on this? A lot of information, and I know it's the first time you're seeing this in any math course. Okay, so we'll wrap it up. Thank you so much for your patience, and especially here in the, only in the live session. And let me know anytime I can help. So to everybody in the recording, thanks for watching. We'll have our next session Friday at 3. In the meantime, please don't be frustrated. And if you are, I will get you past wherever, past that. So everybody in the recording, bye for now.